All right, so we'll begin with introduction to databases. What is a database? A database is an organized collection of data that is stored electronically. Electronically here will mean like in a computer, because in a local store, the ledger that people like record their daily sales and everything, we can also consider that as a database. So here we'll be saying that the electronically will mean a computer, and it can be accessed, managed, and updated. Okay. So instead of storing data like in files in our computers, data is being stored in a database. And a database handles large amounts of data, can be accessed and used by multiple users at the same time. The database provides security, consistency, and reliability. Okay, when we talk of provide security, like we like in databases, we have something they call access specifiers. Let's take a example, a scenario like in a company. Let's say a junior staff just gets into a company. That junior staff, or rather, let's consider an e-commerce company, which is on site, not online. So a junior staff that just got recruited cannot like have access to the company's data when a database for sales. Please, are you with me?
Yes, I'm with you.
Yes. So a junior staff who just got recruited cannot have access to that. And even like a customer that a customer too that buys services from that company cannot have access to that company's data. Then when we
Okay.
talk of a database like being consistent, it means that the data values are consistent. Permit me to use the same like consistent to define consistent. It's consistent like in all its copies, because in a company, let's say a company that is located in the US and has workers, let's say in Cameroon or in Nigeria, working on the same database. In all of those, the workers in those different countries, the data in those databases is the same. It's consistent. Did you get that?
Yes.
All right. And it's also reliable, means you can get it at any time. An example of a database, here we have a student database that stores student ID, the name, the course, and the grade. The name of the student, the courses that are being taken by the student, and the student's grades. That's what this database is going to be holding. Database management systems. Database management system is typically a program or a software that allows a user to interact with the database applications, with the database and applications. So some activities that that a database management system does is like it helps the user to read from a database, create, update, and delete data in a database. Yeah, that's the CRUD operation, CRUD, where C stands for create, R RU to read. That's like retrieving data from the database. Then you can also update, and then D, which is delete. You can delete data from the database.
Okay.
All right. We come now to the functions of a database management system. A database management system stores and retrieves data. Like we've spoken about the the create function. So with with a database, you can create. Sorry, please excuse me.
Okay.
All right, functions of a database management system: data storage and retrieval, data security and access control. I think we mentioned this access specifiers above. Like with a database management system, this can be enforced. Not everybody will have access to that. That is being management system. Then with a database management system, there's always backup and recovery of data. Concurrency control. Multiple users can use the database, like the instance of having workers spotted in Cameroon and in Nigeria. All of them using a database management system can all access the database at the same time. Data integrity, which talks about the accuracy of data, its consistency, its completeness, and reliability. I'm going to explain that. So, understanding data integrity. Data integrity ensures that data is accurate, consistent, complete, and reliable throughout its entire life cycle, protecting it from corruption, loss, unauthorized changes, making it a trustworthy asset for decision making and operations. When we say data integrity ensures data accuracy, we're saying that the data in the database is free from errors and it reflects real world facts.
When we
When
see
we say,
the sorry, you should explain the data life cycle to me first. Talk about the data life cycle. Even if it's just an overview, there are additional resources there, but giving an overview.
all right, so I'll try to explain the data life cycle. The data life cycle here involves the creation of data, where data when data is being generated. It could be generated from surveys, like from inputs, like on a website now, if they are taking like other details, like total sales from a website, that data can be gotten like from the number of sales. So that the input source, sensors, and transaction. Then data acquisition. This refers to data capture, like how data is captured and how data is gathered. And how is this done? This can be done from surveys. We also have, what do you call these? Okay, when people come and give you forms to fill, okay, that's surveys. Then also inputs from websites. You can also get data from there. And even from interviews, like if you interview people one on one, you can also get data from there. Data cleaning, this is transforming data, removing what is not required. Let's say you are gathering data for people who are potentially diabetic. Yeah, people who are potentially diabetic, and you like input the data for a child who is like 15 years old. And we know that a child who is 15 years old, the child has like the normal weight and also the blood pressure. So with that kind of data, we'll have to like delete it from the data set because it does not like fit in. Because someone who potentially has diabetes is most likely someone that has high blood pressure is overweight, does not sleep, sedentary lifestyle, or is staying in the same place for a long period of time. So a child who comes in that has like ages 15 and has the normal weight, that's going to be abnormal data. So cleaning that data will be us deleting that child from the data set. And we also have storage, where storing data in databases or in warehouses. Then also part of the data life cycle, we have data management, where data is being accessed, data is being manipulated or visualized for decision making. Then we can also have data distribution, where data is shared with authorized users or systems. Then we can also have data destruction, where the data is securely deleted when it is no longer needed. This is that good with you?
Yes, but it's what you're explaining is not in the notes, right?
No, it's not. It's not in the notes. This is found in the extra resources. I think at the end of the of this course, it's an extra resource.
All right.
Yes.
All right.
So we were on understanding data integrity. So data integrity ensures that data is accurate, consistent, complete, and reliable through its entire life cycle. I just briefly explained the data life cycle, protecting it from corruption, loss, unauthorized changes, making it trustworthy, making it a trustworthy asset for decision making and operations. So when we say data integrity ensures accuracy, it means that the data in the database is free from errors and reflects real world facts. Then data completeness. When they say data integrity ensures completeness, we're saying that all necessary data fields in the database are present. Let's picture the scenario of a database for a student table, where we have to record student name, student ID, student age. That data is complete when you have all of this information: student ID, student name, student age. If the student age is missing from the student table, that data is not complete. You got that?
Yes.
Yeah. Then talking about consistency, like data integrity ensuring consistency. Using the same scenario, like saying that a company is in the US and has remote workers in Nigeria and in Cameroon. Data is being consistent here when the database in the US is the same as those here in Cameroon and those in Nigeria. If it's the same, then the data is consistent. Data integrity ensuring reliability. Data is stable and produces a consistent result. Examples of databases, we have the MySQL, Oracle, PostgreSQL, and MongoDB. Advantages of databases. Advantages of storing data in a database. It reduces data redundancy. Let's say we go to like ISC Learn, those who are taking this course online. If you go to that data to the ISC online trainees and Lovett appears two times, that's redundancy. And with databases, redundancy can never occur. So that's why we say with databases, data redundancy is reduced. Improve data consistency. I explained it all with the example of a company in the US and having remote workers in Cameroon, Nigeria that are accessing the same database with the same data, that's it being consistent.
What is data redundancy?
Data redundancy is like in a
No,
database.
you're explaining to what then?
Okay. Like if you have in a database, student database, and it has a table called, let's call it student credentials. It has fields ID. Yeah, it has fields ID, student first name, student last name, and email. Then now we have records. Let's say record one. The first name is Lovett.
What's the record? Really? Don't just don't worry. Like, go ahead.
Okay. I thought okay. Okay, Lovett. Sorry, let me come back. A database is it's a collection of data stored in, we could say, tables. That
Relational database.
okay, a relational database is a database where
The types.
okay, like for example, we have, like, if you go to types of databases, a relational database is one. So this example that I'm trying to give here, I'm using a relational database where data is stored in tables of columns and
Okay.
rows. Where, yes, where the row is a record and the column is a field. So in this example where I want to explain data redundancy, we have we have fields ID, first name, last name, and email. And email, those are fields. Then to have our first record, let's say our first record is Lovett for first name, and then your last name, let's say, is G. Then your email. Then the second, if the second name comes again and it's still Lovett G, then this particular data is redundant because it is repeating itself. So data redundancy is when data is repeated in a database.
All right.
Yes. Then advantages of databases: reduce data redundancy, improved data consistency. It means the data being the same throughout. Data security. Data security, I think, is going to go with data access because not anyone can access the data in a database. Data backup and recovery, because with every database, I believe there's a backup. So there's data backup and recovery is ensured. We come now to types of databases. We have relational databases, non-relational databases, also known as SQL, object-oriented databases, distributed databases, and cloud databases. So here we'll be focusing on relational databases. What is a relational database? This is a database that stores data in tables, as I was trying to explain in the example above. A relational database stores data in tables, that is, in rows and columns, where these rows are referred to as records and the columns are fields. You got that?
Yes, I got that.
All right. In a relational database, we have tables where each table represents a real world entity. Like if you go to a school database, a student is a real world entity, and that's a table on its own in a school database.
All
Or
right.
we can use the example of an e-commerce site, a customer, a product, a price. They will all appear in a database as a table, which are real world entities. And a relational database has a primary key. A primary key is used in a database to uniquely identify a record. Like let's say we have,
Okay.
taking the e-commerce site still again for example, for customers. A primary key is going to uniquely identify a customer, each customer in the customer table.
Okay, like in school, like a magical number.
Yes, perfect. Your matriculation number uniquely identifies a student in that department.
All right.
So this is an example. We have the students table where the student ID here is going to be the primary key that uniquely identifies every student. So we so the student, the name and the course, these are all fields. These are all fields, also called columns. Are you seeing how I'm trying to highlight?
Yes, I'm saying.
Yeah, like coming down vertically. These are columns, and columns are also known as fields. These are columns. Then these horizontally, these are called records, also known as rows.
It's a line like this, vertically that. Try to explain.
I'm highlighting it. So key concepts in relational databases. Tables. Data is stored in structured tables. That's columns and rows. And each table represents one entity. Like taking that, excuse me, like taking for a school, a student is a real entity, same as the courses. We could also have teachers because a teacher is a real entity. The teacher's table, a teacher is a real entity. Then we come down now to the keys. A primary key, you got what I explained about a primary key, where you use the example of a matrical number, a student's matrical number.
Yes, about it uniquely identifying a record.
Yes, and in the case of your example, a student's matrical number uniquely identifies a student in a department. Then we have now a foreign key. A foreign key, this is when, let's consider the scenario of, we have a teacher's table, we have a teacher's table, we have a student table, and we have a course table. You got that? We have a teacher's table,
Yes.
we have a student table, and we have a course table. So a teacher's ID will be the primary key for the teacher's table to uniquely identify every teacher in a department. Same goes for a student ID. It's going to uniquely identify each student in that department. And then now we can also have the course table, and we'll have the course ID that uniquely identifies every course being taught in that department. So for the teachers table, we have the teacher's ID as the primary key, the student ID as the primary key for the student table, and the course ID for as the primary key for the course table. So when a primary key, um, so one student, we could say one student can be taking many courses. Is that true?
It is.
Yes, one student can take many courses. So we have here a one to many relationship. So now a student takes many courses. It means the student ID here is going to be now another key in the course table, because there's a relationship between the student and the course. So now a student ID becomes a foreign key in the course table because it's a primary key in another table. Did you get that?
Yes.
All right. So we come now to relationships. in a database, the one-to-one relationship. In this case, we would say one record in a table links to exactly one table. Sorry, links to exactly one record in another table. So in a one-to-one relationship, we're saying that one record in a table links to exactly one record in another table. So let's say we have table A and table B. One record in table A links exactly to one record in table B. So let's say we have a citizen's table and passport table. One citizen, let's say Lovett. Lovett has one passport. So the relationship between citizen and passport table is one to one because one citizen has one and only one passport in this scenario.
Okay.
All right, with one to many relationship. This occurs when one record in a table links to two or more records in another table. Let's consider a customer who is buying from a website. One customer can purchase many products, and that would be a one to many relationship. Coming down now to many to one. Many products can be ordered by one customer. This is when multiple records in a table links to one and only one record in another table. So here we're taking the products table and the customer table, where many products is being ordered by one and only one customer. You got We also have many to many relationships. In a many to many relationship, many records in one table they link to many records in another table. You could also say others contain many products and one products appear in many others. Did you get that on relationships?
Yes, I've ordered on relationships.
Okay. SQL, which stands for Structured Query Language. This is a language that is used.
Your lines are breaking.
Love it. So I want to be sure that you understand so far what is the difference between a database and a database management system.
Please, can you rephrase?
What is the difference between a database and a database management system?
Well, a, a database management system is a software, and database is just a collection of data that is stored digitally, and it can be updated and managed and accessed. Why the database management system is a software that allows you to carry out this database activity.
All right, that's good. So what is a relational database?
Relational database is a type of database that uses tables to store data, where it has rows and columns, and columns store records. Records are stored in columns, from what I understand. And yes, so far that's all.
Come again, you said records are stored in columns.
No. Wait. Yes, records are stored in columns from left to right.
Faith, can you clarify here?
Okay, love it. A relational database is a database that stores structured data in tables. That table, it's a column and a row. The table has columns and rows, where you can also refer to a column as a field and a row as a record. I'll take it again. A relational database is a database that stores structured data in tables, and this table is made up of columns and rows.
Okay.
Yes. And you can also refer to a column as a field and a row as a record.
Okay.
So is that understood? So
Yes.
I'm back to the are you seeing my screen? I'm here to the example of a
I'm seeing
table
it.
where we have the students table. Vertically, like if you are drawing a line from north to south vertically, those are columns, also known as fields.
It's
Then
okay.
if you're drawing a line horizontally, are you seeing it like this?
Yeah. Left to right is row.
Yeah, that's a row, also known as a record.
All right.
Great. So we'll proceed to SQL, structured query language. This is a standard language that is used for storing, manipulating, and retrieving data from databases. And you did you get that?
Yes.
It's a standard language for storing, manipulating, and retrieving data from databases. Common SQL commands. We have the select. Select is used to retrieve data, like to fetch data from a database. You use the select command to fetch data from a database. Insert, to add data into a database, to add data into the database. Then the update command is used to modify data. Maybe you want to change a column name, you want to change it to another thing, you will use the update command. The delete command, you use it when maybe you want to remove data. Let's say you have a database that has 10 rows and you want to reduce it to 5. You use the delete command to reduce it. Is that okay?
Yes.
Okay, advantages of relational databases. They are well structured and organized. Given the fact that they are stored in well defined rows and columns, means they are structured and organized. Strong data integrity uses standardized SQL to communicate with the database, suitable for complex queries.
Sorry to cut you short. We've talked a lot about data, but then you've not told them what exactly data is, how to, categorize it and all.
Okay. All right, love it. We're going to talk on data. Oh, Azibo, welcome to the call.
Thank you, madam.
You can call me Faith. I'm also a trainee at ISC Learn.
All right. Nice to meet you then.
Okay, so we continue with data and information.
Okay.
Data is a collection of raw facts. This could be figures, symbols, or
Mm-hmm.
observations of an event. I think in secondary school they always tell us that data is raw fact, right?
Yeah.
Yes. So with data, data in itself it appears meaningless. Let's just say you go out and you collect the name of all people who are in the market today and their ages from a certain period, like only in the morning. That's data. Those are figures, observations. Yes. So data by itself can appear as meaningless, but when it is organized, processed, and interpreted, it is transformed into valuable insights, which we now call information. So data is a raw fact. Then when it's being processed and interpreted, we call it information. So you can as well say information is processed data that can help individuals to make decisions and solve problems.
All right.
Okay. So types of data. Data can be categorized in different ways depending on how it is collected, stored, and represented. So data is broadly classified into two. Data could be quantitative or qualitative. And under quantitative data is data that can be counted, data that can be measured, or data that can be expressed in numerical form. And under quantitative data type, it is further divided into continuous and discrete. Yeah. So data is broadly classified as quantitative or qualitative. Then looking at quantitative data, it could either be continuous or discrete.
When it
So
says discrete, what does it mean?
yeah, I was coming to that. For discrete, I'll use an example to explain it. Like your age.
Um,
Your age is a
okay.
is yeah, your age is discrete data. The total number of customers that a company records in a day. We cannot have like 20.5 customers who came into our office today. It must be 20 or 21. That's discrete data. Then when we come now to continuous data, an example for continuous data could be your weight, your temperature, or even your salary. That's continuous data.
All right.
Yeah. And we also mentioned that data is also can be classified as qualitative. So qualitative data is data that is descriptive, data that is non-numeric, a data that explains quality and experiences. With this type of data, we can best understand opinions, experiences, or reasons for a behavior.
Okay.
This data records quality or attributes rather than numbers and can be collected, let's say, in surveys or interviews. We could take like the best scenario, like when we use a service online, I think they always tell us a
Tell us
rate
to.
to rate like customer like ratings.
All
Like
right.
like ratings, were you satisfied? Were you unsatisfied? That's a qualitative data.
Okay.
and also maybe your observations. Let's say a new feature is let's say a new feature is introduced to WhatsApp. The data
Mm-hmm.
that WhatsApp can get from there is how quick users are easily are attracted to that new feature. Like
All right.
when they get to the application after the first 10 minutes, they have noticed that new feature. That's qualitative data.
Mm-hmm.
We also have structured data. Please permit me, I forgot something. Qualitative data is also subdivided into nominal and ordinal data. Are you with me?
Which one?
Qual-
Quantitative.
no,
Yeah,
I
qualitative.
said qualitative.
Okay.
It's subdivided into nominal and ordinal data. An example of nominal data could be your color, your gender, your
Mm.
gender. Then for ordinal data, ratings, users' experience or observations.
Those
That's
are
ord-
the ratings.
yes, that's ordinal data. So I'll try to summarize again for qualitative and quantitative because the names can be confusing. So for quantitative data, this is data that can be counted, measured, or expressed in a numerical value, and it's subdivided into two: continuous data and discrete data. For continuous data, it could be your salary, it could be your age, it could be your temperature. While for discrete, total number of customers that walked into an office in a particular day, that's discrete. Your age, your age is also discrete. The number of containers in a supermarket pallet, that's discrete data.
Mm-hmm.
Then we move now to qualitative data, data that is descriptive and is non-numerical. It's used to
Is that how that is?
data that is descriptive
Mm-hmm.
and non-numerical
All right.
is data that explains qualities, experiences, and opinions, and also reasons for certain behaviors. That's qualitative data. And it's subdivided into two. We have ordinal data and nominal data. An example of nominal data, you could have color, gender. For ordinal data, we could have ratings, experiences, observations. Like maybe you go to the market on a rainy day, you observe that since it was raining, many people did not come to the market in the early hours of
Mm-hmm.
the morning, let's say from 6 a.m. to 11. But from 11 to 2, rain was no longer falling, and you notice that many people came to the market at that time. So that's an observation.
All right. That one falls under ordinary data.
Ordinal,
Ordinal. All right.
ordinal data, yes.
Mm-hmm.
So far we've handled two types of data. We've handled quantitative data and qualitative data, which have their subs.
All right.
The third one is we now have structured data. Structured data is data stored in organized formats like rows and columns. Like we have spreadsheets and databases.
Is data
Structured
stored in organized what?
organized formats. That
All
is
right.
rows and columns. And this could be spreadsheets or databases.
All right.
For the fourth one, we have unstructured data.
Mm-hmm.
Yeah, this is data that does not follow like any predefined structure or format. It could be a PDF, it could be an email, it could be a video, a voice note. That's unstructured data.
So it's just the opposite of structured.
Yeah, can say that. We have then for the last one, the fifth. How many have we counted so far?
Quantitative, qualitative, structured, and unstructured. That's four, five,
That's four.
four.
And for the last one, we have semi-structured data.
Mhm.
It's a combination of both unstructured and structured data.
Okay, the combination of the two.
Yes, an example would be a JSON file.
What's a JSON file?
JSON file stands there for JavaScript Object Notation.
Okay.
Literally, it's an object. Let's say, please, what's your name? No, no, not love it. Please, the other person on the call, could you please your name? Hello.
Yes, madam. I
Azibo.
don't.
It's
Yeah.
Azibo.
Azibo.
Mm-hmm.
Okay, Azibo. So we could see an example of a JSON file is like an object, like data is being stored in key value pair. Like if I have your name, let's just take it as data is stored as key value key. You have the key and you have the value. Let's say the key is your name, like name. Then the value now will be Azibo. If you have another key which is age, the value now, let's assume you're 60. The value
Mm-hmm.
is 60.
All right. All right.
So a JSON file stores data in key value pair. Madam, what I've explained is not an example.
Like show the example of the
I also wanted to ask. I'm trying to follow the notes, but I'm not seeing. I'm just seeing introduction to databases or what you just explained. I'm not seeing them in the note because I would like to
Okay,
go through that.
it's not in this particular slide, but it's there in the previous slides. I just had to like bring this in so that you understand databases, relational database, because I've been talking a lot about data. So I
All
went
right.
back to explain what data is.
Okay.
I don't know if you like example of the JSON file. Please, I'll come back to that. A JSON file as an example of semi-structured data. Okay. Let's use this. Like it stores data in key value pairs. An example, let's say there's a user called Azibo.
Mm-hmm.
What's the data that is being stored? Your name. Or rather, let's say we have user one. Let's consider user one. How is it going to store user one's data? It's going to store it as an object, key, and its value. So user one is going to have the first key there is going to be name, and that name is Azibo. The next key is going to be your age, and its value is 60, assuming. Let's take that
Okay.
60. Okay, this is my screen. Are you seeing it?
Yeah, I'm seeing your screen.
Yeah. Are you seeing user one, two, three,
Yes.
the arrow, and you have your name? So this is it. So the name here is a key, the age is a key, then the corresponding values now you have Alice and you have
Okay.
20.
Age.
That explains, sorry, H, that explains the name key value pair.
All right.
Yes. Oh, this is really down. We're still up. So that's it about data. Please, is that understood? Like you've
Yeah,
Yes.
gotten
I'll still
quantitative
go
data.
over it.
Or can you run me through the types of quantitative data?
We have continuous data and discrete. Now, you explained that the discrete quantitative data is one. The example is like a palette is fixed, a palette of water.
Yes.
Mhm. And then under
Okay,
continuous,
wait.
you
Hold on. Oh, okay. Palette of water falls under discrete. Same as your age. Your age too is an example in that same category.
change.
Yes. Not that it cannot change, but it's a whole number.
Okay, okay.
It's a whole number. Like the number of
How,
customers that walk
how
into a
about,
bank.
yes, I wanted to also give that.
Yeah, like the number of customers that walk into a bank in a day. That's discrete data because the value there is whole. We cannot say 31 and a half persons walked into the bank. It's either 31 or 32, not 31 and a half. So that's discrete data. Your age, total number
Mhm.
of customers, using the same scenario for the number of containers in a pail of water. You cannot
All
have a
right.
half bottle. Yes. So that's
Mhm.
discrete.
And then under continuous is the one that you can have those halves
Yes. Your
like
salary. Please go
okay
ahead. Go
salary.
ahead.
No, it's okay.
Then for under qualitative, this is descriptive data that explains or describes users' experience or meanings behind certain behaviors, and it could either be ordinal or nominal data.
Mhm.
Went ahead to define structured data, unstructured data, and semi-structured data.
Can you please explain me semi-structured again?
Semi-structured is a combination of both unstructured data and structured data. I was trying to scroll down. Are you seeing my screen?
Yes.
Yes. So this is a perfect example of a JSON of an object, which is a JSON file.
All right. It has the user, the name, and the average, and the
Yes.
age.
Yes. When you talk of JSONs, you must always like mention keys and values. In this case, the name and the age are both keys. Then H and 20 are the corresponding values.
All right. All right.
So I'll scroll up and we'll go back. Please, is everything understood under data?
Yes, madam.
I'll scroll up to CQL. Structured CQL, which stands for Structured Query Language, which is a standard language used by, should I say, users to interact with databases. They use it to like to store, manipulate, and retrieve data from a database.
Okay.
Yes. So common CQL commands, the select command. The select command is used to fetch or retrieve data from the database. You have the insert. The insert is used to add data into the database. You have the update, just like its name is to modify. Like if I want to change from, if I have a student table, and let's say I have first name and last name as columns, and I want to change the first record in that table, which is already very Azibo, and I want to change it to Loved, I will use the update command to do that modification.
All right.
The delete command is used to remove data from a database.
Wait, when you say this update command, for example, if we like put a name but it's not spelled correctly and you come and correct the name, that means you've updated it.
Yeah, that's an update.
Okay.
Advantages of relational databases. Since they are since they are stored in tables now, that's columns and rows, they are
That's
obviously structured and organized.
okay.
Then we have strong data integrity. Strong data integrity uses standardized SQL uses standardized SQL. So we use the structured query language to interact with relational databases, and relational bases are suitable for complex queries. Limitations of relational databases. It is less flexible for unstructured data. Remember what unstructured data is?
Mm-hmm.
Like emails, PDFs. They cannot be easily managed in relation when stored in relational databases.
Okay.
Can be harder to scale horizontally. Can be harder to scale horizontally.
All right. So when it comes to this, reduce your volume. So when it comes to this point of relational databases, where she says that it can be hard to scale horizontally, we're just going to talk a
Mhm.
little bit about scaling so that you properly understand. Before going into it, what do you guys understand by a server? What is a server?
Mm, we can say that a server is like a cloud where information. A server is something that runs like a server is, I don't know. It's like a cloud. Like you can have another. It's a space, something like that.
A space that does what?
Uh, Manages information and data.
All right. Love it. What do you think? Rollins, I also want to hear from you.
Oh, I think a server, a server is a computer
Yes.
that collects information from a client and
Okay. Rollins, please try before we go ahead to explain. Rollins, are you there? Okay. I'm seeing orange for him, so perhaps his network is not stable. A server is a computer, as Robert said, or it's software that is used for rendering data, providing services, and all. So, talking about a server, I think the best way to explain it is using the client server architecture. The client server architecture, I don't know if you guys have done this yet with Yannick, but definitely we'll get into it. On networking and the internet, how communication happens over the internet. You make a request to a server using your browser. So your browser is acting as the client in this client server architecture. right? So when you make that request, the server then receives the request, and based on the request, provides a corresponding response. So in this case, it really depends. There are so many structures to it. Now it sounds very simplified, but there are actually multiple servers that are communicating in the background. So sometimes the server could be a software, right, that routes your request maybe to the dedicated program that is running. That we're going to see all of that when we get towards the end of the program. Or it could also be a machine, right, that holds now the actual data, and when you make that request, okay, it gets routed there, and then the data is sent back to you. So a server in simple terms is just for providing services. Now, a server can also be your computer, your personal computer. You can set up your personal computer as a server. But then, of course, okay, so I was saying that you can turn your computer into a server, but then it means it needs to be on 24/7. Okay. Now, you see the way your computer has its specifications. Okay, it has, let me say, 2.30 gigahertz of processor speed. It has maybe 16 gig of RAM. It also has storage, maybe 1 terabyte SSD, and so on. Right. That is how these actual physical servers also have their own specifications or their own capacities. Now, when we talk about scaling, the reason why you scale is because you have more load than your server can accommodate. Let's say that, take your computer, for example, your personal computer. Perhaps with your processor speed and your RAM and your space, you can only contain a certain level of information. Let's say with the specifications you have, you can only have, let me say, 100 movies, for example, of 1 gigabyte each, right? That is
Mhm.
the maximum. But then you want to start adding more movies. However, your computer cannot take this load because it's beyond its capacity. So what do you have to do? You now have to scale. So it's a similar thing when a server starts receiving more requests or starts holding lots of data than it can contain, then you need to now scale. So you can scale in two ways. You can either scale horizontally or you scale vertically. Scaling
Mhm.
horizontally means scaling out. What does this mean? You're getting another server or another computer so that you distribute the load across it. So take for example, if you had, let's say, an 8 gig RAM server and maybe 1 terabyte SSD, for example, and that cannot contain your load, you now get another one, maybe another one which is 8 gig, another one which is 16 gig of RAM and whatever capacity, such that when more requests comes in or when you need to hold more data, you distribute it now across those two servers. In a similar manner, you can add a third server, add a fourth server, right up to the end server, right? So you're scaling out, you're just getting more machines and distributing the load. But then when we talk about scaling vertically, that's scaling up, right? It means that on the same machine, you're just increasing its specifications or increasing its capacity. So on your same machine, instead of maybe going to get another machine that is 8 gig or and 1 terabyte, you just now come and add that 8 gig to the existing machine that you already have. So when we
Mhm.
talk about scaling your databases, for example, it means that distributing these databases into different parts or putting it in different servers. In order for you to do this, there's something called database sharding. You can read more on it. It simply means that you're splitting your database into different parts such that and putting it on different locations such that the load can be equally distributed across each database. There are many
Mhm.
reasons for it. Sometimes you also want your request to be processed faster and so on. So that is the whole concept of scaling. Faith, you can continue.
Yes, Miss Mira.
Your mic is muted. Hello?
It's on now.
No, your mic is muted. Oh, yes, it's on. Hello, publish.
All right.
What's ringing you at the moment?
We've understood the scaling horizontally. Schema must be predefined. The schema here, it's like determining the relations of your tables in your database Like we already spoke of the one to one, the one to many, the many to one, and the many to many relationship. These are the different relationships that you can have in your database schema. So if you've not defined this schema, you cannot go into saving data in a relational database.
Okay.
Please, are we on board?
Yes.
Yes.
Oh, sorry, I reduced all my volume. Please, are we together?
Yes.
All
We
right,
can hear
thank
you.
all right, thank you. So examples of relational databases, we have the MySQL, the PostgreSQL. This Postgres, this one is actually what we're going to be using in our course. Henceforth, this is what we'll be doing. We also have the Oracle database, the Microsoft SQL server. Resources to read on these, they are down at the end of the PDF of this resource.
All right.
Non-relational databases. These are databases that store data without fixed tables or schemas. Fixed tables means in this database we have no columns or rows, and we don't have like the relationships are not really considered. So these databases are being designed for large scale applications, high performance and flexible data models. It means when they say flexible, it means you can easily add to the database or delete, because with this one, the schema here is defined. When you just add anyhow, I think you alter the schema. Non-relational databases are often called NoSQL databases. Types of NoSQL databases. The key value pair database. Yeah, I had explained this, that you have the key, using this as an example, the user 123, where you have name and age as keys and Alice and 20 as the values. Thank you. So that's it about key value databases. There must be a key and there must be a value. They are very fast to access. So that's it about key value databases. Then we have document databases. Store data as JSON or XML. This XML stands for Extensible Markup Language documents. I think like we have .html, we also have .xml.
XML.
Yes,
So this
such
this one is for larger files.
yes.
Okay.
And it's an example of document databases. An example of such a database would be MongoDB and CoachDB.
What are those?
These are types of non-relational databases. In this course, we're focused on the Postgres, so I don't really know much here as a trainee, but you could do more research on this.
Okay.
AM Messenger.
Column-oriented databases. They store data in columns instead of rows, efficient for analytics. Example will be the Cassandra and the HBase. All of these databases, they are still new, so they just like read through them when we're being taught to. We have the graph, number four, the graph databases. They store data as nodes and relationships, best for connected data. An example would be the new 4J. Like this is just for you like to have an idea of other databases, but our focus is the
Some
Postgres,
PostgreSQL. All right.
PostgreSQL for this course. So advantages of NoSQL databases: schema flexibility, horizontal scalability, high performance for big
Are you there?
So that's something a network.
Mm. Probably they've cut like where they are.
Azibo.
Probably they don't have light or something.
All right.
So I'll just be around. I don't know until she can come back.
Okay. Same here. Azibu, I'm logging out there. They'll just have to communicate via the Discord channel if they'll come back.
All right. Okay.
Yeah.